In this example, we're going to demonstrate how to combine Kirchhoff's current law, Kirchhoff's voltage law, and Ohm's law, our fundamental laws, and solve a circuit. So let's just kind of recap what those are. So Ohm's is V equal to IR. Kirchhoff's current law is the sum of the current in is equal to the sum of the current out. And Kirchhoff's voltage law is the sum of the voltage around a loop is equal to 0. So those are our fundamental laws that we're going to use. We're going to be able to use them to solve this circuit. So generally, you're going to start with either KCL or KVL when you solve this entire circuit. We are looking for, if you read the problem, we're looking for V0 and we're looking for I. So we need to know both of these things. So we have two unknowns, which means we're going to need at least two equations. So let's start off, because everything's in this one big loop, let's start off with a KVL, because it likes loops. I'm just going to label a loop here as loop 1. So we're going to go around and say KVL around 1. And that is the sum of the voltage around that loop is equal to 0. So I'm going to start down here, and we'll work my way around. So we're going to get minus 12, and then I get to here, and there's no voltage. So it's okay to add things to your circuit. You can label things. Follow your passive sign conventions. So if I have a current going this way, current wants to go from high potential to low potential. So that means it wants to go from a positive sign to a negative sign. So we are following passive sign convention as we add that. And then I'm just going to give it a label. I'm just going to call it V4 ohm. So then we'll say plus the voltage of the 4 ohm resistor, and we'll sub that out later. So let's keep going. Plus 2 V0, and then we're going to pick up a minus sign here. So minus 4, we don't need the V. The V is not a variable. We included the V0 because this is a variable on this one. And then minus V0, all equal to 0. So let's count up our variables. We have V0 as one variable, and we have V4 ohm as two variables. V4 ohm is not the I that we want, so we need to do a substitution. So we'll call this equation 1 for now, and we'll move on. So our next equation is going to come from Ohm's law. We're actually going to use Ohm's law twice. So we'll use Ohm's law at this resistor. So V4 ohm is equal to I. Well, the I there is this current I, and the resistance is this 4 ohms. So we can rewrite that as just 4I. And so now if I want to, I can sub this in right here. And so I still have two unknowns, but now they're the unknowns that I want to do. So I need another equation to finish this up. And your last equation, so generally what's going to happen is when you see a dependent source, it's going to have a dependent variable. Your dependent variable will almost always be labeled across a resistor. Go to that resistor and write Ohm's law. So let's write Ohm's law at that resistor, at the 6 ohm. Sorry, I should have said Ohm's at the 4 ohm. It's nice to tell me what you're doing in case I have to give you partial credit. And also anybody else that looks at your work, they know what law or method you're using, and then you kind of show the work. So at the 6 ohm, so the base equation is V equal IR. The voltage there we know is V0. The resistance is 6. And so what is the current? Well, if you remember, there was a quick thing about series and parallel. This current I will go through here. It won't have an option, so it'll go through here. It won't have an option. The current I is through all of these elements. So we'll have I there, we'll have I there, we'll have I there, and we'll have I there. Now I know that this is not passive sign convention. That's okay. We don't want to change the direction of the arrow. You just want to follow it around. So this is I. And so if I just put in I, this is going to be wrong. So 6I is going to give us a voltage this way, which is the opposite of this. So technically, you put a negative sign here. If I put the negative sign in front of V0, then it'll flip my polarities on my V0, and I'll be fine. we can't change the direction of I, but I can say that this is negative, positive, and then I can put a negative V naught inside of here. So that's what we're doing. So that we have positive, negative with this. So a passive sign convention is being followed, and then we have a negative V naught inside of that. So that's our last equation that we need. And then you just combine these equations. So let's solve this for here. Let's simplify this thing down first. So we'll have negative 12 plus 4i. We have 2 minus this, so that's a plus of v naught. Oh, and we have 12 and a 4 together, so that's a negative 16. All equal to 0. So when I combine 1 and 2 together, I get this equation. And then if I put in the, so v naught is equal to negative 6i. If I plug that in with this guy, oops, sorry, you couldn't see that. So let me just rehash that. So we put these together to get this, negative v naught, I, and then 6i. I'm going to sub in for the v naught, so I just make this a v naught equal to negative 6i. Push that in there, which becomes this equation. Solve for I is negative 8 amps. And then you plug this negative 8 amps back into this equation, and you'll get V naught is equal to negative 6 times negative 8, which is 48 volts. We used only things that you already know. Ohm's law, KCL, KVL. We did have to take advantage of series, and then there's also parallel. So I believe in your example, you're going to have three components in parallel. So you'll have to make sure that you know that it's the same voltage across all of them. Okay, same signs as well. So they'll all be plus at the top or plus at the bottom. So the signs won't flip.